Hi there. Right, I've just built up a couple of my new micro pulse rifle boards and I just wanted to run a little test on them. I've had a previous customer who used to run one of the previous versions of this board off a pair of CR2032 button cells. He's been experimenting with one of the beta versions of this board, and apparently when you try and run this board from button cells, it powers up and then a few seconds later it powers off again. So let's have a look. I've got two button cells here. Let's connect them up in series, so it should give about 6 volts. It comes on and apparently it'll turn off after a few seconds. It's still going. Oh, it's gone. Right. My immediate thought as to why that would happen is these button cells are useless, basically. They contain a tiny electrical charge and can only provide it out very slowly. These boards take about 160 milliamps when idling at the moment. I need to work on the firmware to try and reduce that, but the problem is a large proportion of that is the LEDs themselves. So let's have a look to see exactly what does happen with button cells powered from here, powering this board. Now, let's bring up my multimeter. What I'm going to do, I've got two button cell holders here that I've just soldered together in series so that I can easily connect up the board and the multimeter. So let's first of all connect up the multimeter. Now I'm going to throw those two cells away, and I've got two brand new cells, unused, fresh out of the packaging. One and oh, I wish I was He-Man. Yeah. Come on, why won't this break? There we go. Get out of there, you little bastard. Okay, two brand new, never used CR2032 button cells. Put one in each of these holders, and it should give me around about 6 volts. Come on, in we go. 6.29 volts, 6.3 volts. That's more than enough voltage to run this. Now I want to connect the pulse rifle board up as well in parallel to the multimeter. Wind that wire around that pin there. Okay. 6.4 volts. And then I connect this wire to the positive of this battery, and we'll see what happens to the voltage. Instantly drops. 3.7, 3.6, 5, 3.3, 3 volts, 2.5 volts, and gone. At 2.2 volts it just switches off, can't cope anymore. And actually, interestingly, the battery voltage then rises back up again to 4.4. Okay, we disconnect. The batteries then recover their voltage gradually in the way that batteries do. 5.5 volts, we can put that back on again, and drops down to nothing. Now the problem with these batteries is the internal resistance of them is so high that as soon as you try and draw more than a few milliamps from them, the voltage drop across them plummets. So really they're not suitable for powering anything that needs more than a few milliamps, and LEDs generally need more than a few milliamps. I can reduce the brightness of the LEDs. They are powered by a PWM driver, so they can go a lot dimmer. It won't give such a good effect in your pulse rifle, but it is a possibility. So I'm going to see if I can now connect up a programming cable and reduce the brightness. So I go, programming cable goes on there. Okay, now I should be able to somehow bring this up on the screen for you. Let's take that away. Window capture. There it is. Let's get the colour right. Okay, so we've got the menu. Oops, wrong one. There we go. Bring that up. This is the control menu for the firmware, and the brightness currently is 7. The way I've designed the firmware is, although there's 256 levels of brightness, let's bring this in. Oops, let's just reset. Although there's 256 levels of brightness, because of the way that LED brightness works, you lose a lot of the definition of the brightness at different levels. So I've actually only got 8 levels of brightness, with basically a logarithmic power of 2 scaling for it. So if I take the brightness down, it should give much less brightness, but for some reason this isn't doing it, although actually is that because it needs to restart first? Right, now I think it's too dim to even see. So let's bring the brightness up a little to 3. Let it save and reset. A few seconds as it goes through the bootloader. There we go. Now it's not swamping out the camera anymore. And that's using a lot less current. In fact, if I bring up my power supply now, I need these wires from it. Let's see how much current is being used now. Okay. There's the power supply on. I'm currently set to 3.75 volts, which is about the voltage of a lithium-ion battery. Limit of 1.1 amps, and let's turn it on. If it will. Hello. Nope, the power supply has broken. Actually, I blame my useless USB 3 hub. Come on, connect for me. No, it's not working. I hate this hub, I really do. Okay. Plan B. Although, no, actually I can do this manually, can't I? 55 milliamps, you can't see it on the screen at the moment. Let's see if I can get that just to wake up briefly. No. Just have to take my word for it. 55 milliamps that's now taking, and it looks quite bright on the camera, but in reality it's really very dim. My microphone just fell over there, and it's falling again. Stuff it, it can stay. So if I then take these batteries and connect up again, let's have a look what it's capable of now. Okay, connect my crocodile clips. Okay, and that one to there, and we can see it's almost back up to 6 volts on these batteries now. Connect the board, and it drops down to 5 volts, 4.9. It is still dropping, but it's dropping a lot slower. And to 4.5. Is it going to switch off, or is it going to just hover at around 4 volts? It's certainly lasted longer. .3, 4.2. Remember, it cut off before at about 2.2. Volts. Still dropping. .8. .7. And there's no sign of it stopping at the moment, still going down. 3.5. .3. About 10 millivolts a second it's dropping fairly regularly. I can't see it levelling out and stopping before it hits 2.2. But I guess for completeness I really should let it go all the way. And this is with a brightness of 3, which on a 8-bit duty cycle is equivalent of 2 to the 3. So you're talking 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So 8 in 256, which is tiny duty cycle. My hand's beginning to ache now holding this wire on here. Down into the 2 volts now, 2.9, 2.98. It has slowed a little. So there is a chance that it might last for a considerable time more now. It's struggling now to get down. 2.87, 2.86. Right, I'm going to have to let go, my hand's aching. Oh, I guess I should really have attached it properly, that wire. But anyway, that does show that running it much dimmer does save a lot of power and can allow it to at least run for a while off little button cells. So that is an option. Ideally though, you really want to power it from a lithium ion cell. Just a single one will do. An old phone battery would be ideal. Let's try this one. Here's actually from my old HTC phone, this one. Let's just plug that in. And does it work? No, I think the battery must be dead. I've not used that for some time. Let's try this one. This one's from an old Sony Ericsson phone. There we go. That lights up nicely. And in fact, I'm now going to get my programming cable again. Put it back up to full brightness. And see just how well it works off a lithium ion cell. Okay, increase the brightness up to maximum. Let it save. Okay. And if you remember, the button cells lasted a matter of a few seconds running at full brightness. Certainly doesn't look like that's about to go out anytime soon. Got no way really of attaching my multimeter to this to see what the voltage is doing. I don't think I've got an adapter cable. What can I use? No. No, that's a series. No, I could do with building a little adapter cable to test the battery voltage over time, but as you can see, that's not going anywhere. So really you need to use lithium ion is the ideal rechargeable battery source, and you can just grab an old phone battery and, as I've done with this one, solder wires onto the pads. Or you could buy a brand new battery from a reputable supplier. You can also pick up fairly cheaply these larger cells. They're numbered by the size, 18650, that one is. And I measured this one at 1100 milliamp hours, and that battery should last for quite a few hours. So there we have it. Just goes to show just how naff these button cells are.